Okay, so sorry about that, timer went off. We were talking about here my exponential function. Since its range of that exponential function here, we have only positives, y is greater than 0, that's the domain, okay, of the log. And since the domain of the exponential is all real numbers, that's the range of the log. So the range here would be all real numbers, because I'm going to go down forever this direction and up forever this direction. So really our trick to graphing these log functions is going to be first to look at its inverse, okay, and then flip-flop it, okay, to get the other, okay. So again, now let's go ahead and let's look at what if my base is less than 1 but greater than 0, okay. So let's say my base is in between 0 and 1, okay. Again, the inverse for that function is going to be f inverse x. Again, it's going to be b to the x, but this is going to be an exponential decay because my base is less than 1. Okay, the domain of this function, again, is going to be all real numbers, but the range, and the range of this function, is still going to be y has to be greater than 0, and it's still going to pass through this same point here. The same point here, 0, 1. Oh, it's not 0b. Sorry. Scratch that from over here. It's 0.01. 1, 0. I don't know why I put a b there. 0, 1, 1, 0. Okay, but now it's going to decrease. So now it's going to come down and go like this, because now it's exponential decay. Again, we're still going to have, so here's my inverse function. So when it comes to graphing the log, it's still going to have that reflection. It's still going to have that reflection over this line, this y equals x line. Okay, I probably should have drew it dotted, so I'm going to erase some pieces. Okay, so it's still going to have that reflection. It's still going to go through the point 1, 0. Okay. Okay, but now instead of, again, it's going to be an exponential decay problem. So instead of going up like this, it's going to go down. Like that. Okay. And kind of get that drawn in. So there's our f of x function. This one here, this pink, was our f inverse of x. And just like in this last one, the domain now, again, the orange one was my log, the pink one was my exponent. Again, my domain and range flip-flop. So for my orange here, my domain is now the range of the other one. So y greater than 0, so now my domain is going to be x greater than 0. And the range is now the domain of its inverse. So to graph these, what we're actually going to do is to graph this log. If it's not log base 10 or log base e, we're going to have to look at its inverse first, okay, and get an idea on what its inverse looks like. Okay, so to graph this, the first thing I need to do is find the inverse. So again, to find the inverse, I'm going to write it as y equals log base 3 of x, and I'm going to flip-flop the x's and y's. So x equals log base 3 of y. And then now I'm going to rewrite this log as an exponent. It would be 3 to the x equals y. So now I have it in y equals. So my f inverse of x is going to be 3 to the x. So there's its inverse. So first find the inverse. So we found it. Here's its inverse. Second, graph it, or at least find some points on the inverse, okay? Graph the inverse, or at least plot some points.
There will be a junior class meeting after lunch in the cafeteria. Again, a junior
Sorry
class
about that,
meeting
guys.
after lunch in the cafeteria.
All right, so graph the inverse, or at least plot some points. So I'm going to go ahead and plot some points for this inverse. So we'll go x, inverse x, make sure you don't lose track of what you're doing here. This is the inverse, so I'm going to put some points in here. When I put in a 0, 3 to the 0 is 1. When I put in a 1, 3 to the 1 is 3. When I put in a 2, 3 to the second is 9. When I put in a negative 1, 3 to the negative 1 would be 1 over 3 to the 1, which is 1/3. When I put in a negative 2, that would be 3 to the negative 2, which is 1 over 3 squared, which would be 1/9. Okay, so I have a general idea on what this looks like. I'm going to have the point 0, 1, okay, so forth and so on. So then my very last step, third, is again, flip-flop the x's and y's to plot the points, basically plot the points backwards. Plot the points backwards to graph the function. Okay, because the x's become the y's and the y's become the x's, so now for my function here, my points x, f of x, not inverse anymore, are just going to be the backwards. So instead of 0, 1, we'll have 1, 0. Instead of 1, 3, it's going to be 3, 1. Instead of 2, 9, it's going to be 9, 2. Instead of negative 1, 1/3, we'll have 1/3, negative 1. Instead of negative 2, 1/9, we'll have 1/9, negative 2. So now we just graph them. We'll have the point 1, 0, 1 up 0, 3, 1, 1, 2, 3, 1, 9, 1, 2, 4, 5, 7, 8, 9. We'll go approximately out there, 1, 2. It's going to be right about there. Okay, and then we have over 1/3 down 1. Over 1/9 down negative 2. So it's going to be kind of like this curvy, and then again graph it as a curve. Don't make it all straight, and should be a smooth, nice smooth curve. So this is the graph of f of x. Okay. So again, so you find the inverse, find points on that inverse, and then plot the points backwards to graph that function. Okay. All right.